So this is the first problem. I'm audible, right? Just let me know in the chat. Okay, thanks. So in this problem, we are given that we have three integers and all these numbers are one digit numbers, and we have to find that if there is a way to choose any two numbers from the given three numbers such that the sum of those two numbers is going to be greater than or equals to 10. So I don't think that there's anything to discuss in this problem. You just take the largest two numbers, and if their sum turns out to be more than 10, your answer is yes. Otherwise, you output no. Is it clear? Is it clear? Okay, what about others? It's clear to everyone, right? Okay. So this is the implementation. Here I've taken a vector of size 3 and I'm taking my array A or vector A as input. You cannot actually take this, this is actually this thing. This is C in A. Okay. Don't get confused because of my template. That's not actually the part that is required to solve this problem. That is actually an implement. Like it's not even an implementation detail. That was something that is implemented in my template. So basically, you take three values in input as input, and then you sort those three values. So I've sorted the array in ascending order. So the last two values are the biggest two values, right? So if I add those two values and the sum turns out to be more than 10, my answer is yes. Otherwise, it's no. So is this clear to everyone? Just unmute yourself or let me know in the chat. Okay, what about others? Yes, no, anything? I think that this would be clear to everyone. So let's move to the second problem. So this is the second problem. In this problem, in the game, we are given that in the game show 10 words of wisdom. And let me know in case you find that my voice is too low or like my voice is breaking or anything, like you're not able to understand what I'm trying to say. Let me know, okay? So in the game show 10 words of wisdom, there are n participants numbered from 1 to n, and each of whom submits one response. So the ith response is AI words long and has a quality of BI. Now no two responses have the same quality, and at least one response has length at most n. So the winner of the show is the response which has the highest quality of all the responses that are not longer than 10. So this is also a simple implementation problem. If it's all right with everyone, I'll move to the implementation. It's okay, right? There's nothing to discuss in this problem. So this is the implementation. In this, first I'm taking n as input. Then this is my answer, like which of the players or which of the guys is the winner. And I'm having this X because I want to find out, okay, what is the highest quality in order to determine the winner. So I'm taking A and B as input. If A is more than 10, then I'm simply skipping this player. Otherwise, I'm checking that if the quality is more than my current winner's quality, that is X, I'm going to update my X, and my answer is I plus 1. I is starting here from 0, it's 0 indexed, and I have to output 1 index values, right? So therefore, I'm doing answer equals to I plus 1, and I'm printing my answer. So if it's clear, we'll move to the third problem. Is anyone having any doubt in this? Okay, I'm just saying some people's only in the chat. What about the others? Okay, so let's the third problem. So this is the third problem. In this problem, we are given that we have a 8x8 grid of dots and a word consisting of lowercase Latin letters is written vertically in one column from top to bottom. So which is it? So this is also a simple implementation problem. See, we are given a grid of 8 cross. Okay, let me draw this again. We have a grid of size 8x8. I'm not going to actually draw that 8x8. I'm going to draw a 4x4 grid. Okay, and some of these have dots, and somewhere in between you have a column which has some word written in it. So there are many ways to do this. What I have done, see, start from this cell and just iterate this grid row wise, and the first time when you find a cell which has a character written in it, just try to go down from it and keep going down till you either move out of the grid or you find a cell which has a dot. So this is your final word that you wanted to find. So is the approach clear, first of all? Yes, no, and what about others? Is it clear to everyone? Like, it's just implementation. There is no algorithm or any reasoning involved in this. Okay, so let's move to the implementation. So this is the implementation. In this, I'm first taking my, like, this is a vector of 8 strings. I'm taking my grid as input, and then this is my answer. So finally, my word is going to be stored in this answer string, and I'm iterating through my grid. And when the first time I see that, okay, this cell is not having a dot. So I'll keep going down while my I is less than 8. And I'll keep adding these cells character to my answer. And I'm doing I plus. So this is post increment, right? So first you get this value added to your answer, and then the value gets incremented. So this loop continues, and finally I'm checking if my answer is not equals to the empty string, which is it was initially. So that means I have finally found my complete answer. There is no point checking again, right? So I'm breaking this loop, and here also, if okay, this is this thing. If answer is not equals to an empty string, I'm breaking it. I'm breaking this loop, and finally I can print my answer. So is this clear? Yes, no, anything? Or is anyone having any doubt? Okay, it's clear. So let's move to the fourth problem. So this is the fourth problem. In this problem, we're given that we are one of the authors of Codeforces Round, and we have prepared n problems. So and we are going to set problem I having difficulty AI, and we will do the following process: remove some problems from the list, and it is possible that we remove none of the problems, that is 0 problems from the list, and we can rearrange the remaining problems in any order we wish. So a round is considered to be balanced if and only if the absolute difference between the difficulty of any two consecutive problems is at most k. So finally, we have to find what are the minimum number of problems that we have to remove so that the arrangement of problems is balanced. So first of all, is the problem statement clear to everyone? Yes, no, anything? Okay. Okay, the problem statement is clear. See, we are given some random values, x, y, alpha, beta, and we have to finally, we can rearrange them in these columns in any way. So what do you think? How should we rearrange? What should be the final order? See, if we can rearrange them in any order, we'll sort these values either in ascending order and descending order. Why? because the two consecutive problems shouldn't have a difficulty of A, right? So that's why it's better to solve these problems and then look for a range, for a maximum length range. See, after sorting, let's keep this pointer, let's keep our left pointer here and try to move our right pointer till a point. Like after this, we found that, okay, the difference between the problems, the difficulty of these two problems is more than K. So then this is my left and this is my right. So my left and right will both shift to this place. I cannot have my L and R across spanning these two positions. Why? Because anyway, I cannot have these two, right, problems in my problem set, because the difference between these two problems difficulty is more than K. So now the implementation is quite simple. You don't actually need LNR. You can do this using one single, let's call this okay. Okay, I'm really sorry I got disconnected. My Wi-Fi signal just dropped. So first of all, I am audible, right? Okay, so let's resume from where we left. So this was what we were discussing. I was telling you that we don't actually need the these two pointers. We can just maintain a variable length or x. And how we are going to do? See, if at any instance we find that this value is at k times, like is having like is at least k time k more than this value, then our x is going to be 1 or our length is going to be 1. Why? Because this means if I start from here, if I'm trying to end here, I have to start here only. My problems, like the selected problems, if I'm trying to select this problem, right, I have to start here only. Otherwise, if it's not, if it, the difference is less than or equals to k, then I'll just increment my x plus plus, or you can call it as length plus plus. Like I'm adding one more problem to my selection rate, and answer is going to be maximum of answer, comma, answer is going to be maximum of answer, comma, x, right? So first of all, is this clear? Is it clear? Yes, no, anything? Okay, please repeat. See, we have to remove minimum number of problems, right? So if we want to remove minimum number of problems, we'll have to select as many problems as possible, right? And we can rearrange our problems, but the final requirement is two consecutive problems shouldn't have a difference in their difficulties more than k, right? So first of all, let's sort the problems in ascending order, and then let's try to see if I'm trying to end, or if I'm trying to select this as my last problem, then how many problems I can select before this. See, if I have something x equals to 2, so this means that these two problems can be selected. So if I'm trying to select this problems and have sorted these values in ascending order, I just need to check this and this value, right? If this value turns out to be more than, the difference turns out to be more than k, so I cannot select these two problems. So in case if you're not able to select these two problems, you won't be able to select this problem also with this, right? So now your x is going to be 1, or length is going to be 1. Why? Because you can only select this problem. Otherwise, if the difference turns out to be less than or equals to k, then you can just increment your x or length. That is the number of problems that you have selected. And finally, your answer is going to be maximum of answer comma x. Is it clear now? This. Okay, so I'll move to the implementation part. In case anyone is having any doubt, let me know. So this is the implementation part. First, I'm taking n as input, then k as input. Then I'm taking vector a. That is the difficulty of all of these problems as input. And I'm sorting all of these difficulties in ascending order. Initially, I can always select one problem, right? So I have selected one problem. Val is the maximum number of problems that I can select. So I'm starting from index 1 and x is 1. X equals to 1 means that the 0th index problem was selected. Now, if ai minus 1, so this means that if this problems and the previous problems, the difference between these two problems difficulty is less than or equals to k, I'll simply increment my x. Otherwise, if this is not true, this means the difficulty is differences more than k. I'll make my x equals to 1. That means only this ith index problem can be selected and none of the previous problems can be selected. Val is finally maximum of val or x. That means the maximum number of val, maximum number of problems that can be selected is updated in val. Finally, since I have to output the minimum number of problems that need to be discarded or removed, I'm printing n minus val. So is it clear? Okay, what about others? Okay, so let's move to the fifth problem. So this is the fifth problem, and in this problem, we are basically given that Mirkya has n pictures, and the ith picture is a square with a side length of SI centimeters. And then he mounted each picture on a square piece of cardboard. So each square picture has a border of W centimeters of cardboard on all sides. In total, we used C square centimeters of cardboard. Then we are given the picture sizes and the value of C, and we have to find the value of W. So, see, first of all, let's understand what the problem is trying to say. See, we had some squares. We have some kinds of squares. Then we decided on a value of W, and we gave the border of W to each of these squares. And we finally found this bigger squares, right? These bigger squares for each of these. And this way, these these bigger squares, card boxes were cut down. and the total area, let's call this bigger square area be A1, the area of this bigger square be A2, and this bigger square area be A3. So we are given A1 plus A2 plus A3. This value is nothing but C. So we are given these dimensions, these internal dimensions for each of these squares, and we are given this C, and we have to find this W. So first of all, was someone able to solve this problem during the contest? Yes, no, just write in the chat. Okay, I'm asking this because see, I'll get an idea how much time do I need to spend on this problem. Okay, like there were the majority of the people who weren't able to solve this problem. See, first of all, if we knew W, how to find C? Let's say we know W. So how will you find the value of C? C is nothing but the total area. We can find this for square one. What will be the area of square one? It will be nothing but S1 is its side, right? S1 plus W into S1 plus W. Similarly, for square 2, the area is going to be S2 plus W into S2 plus W, right? 2 times. This will be 2 times. Why 2 times? Because if this is your S1, both of these sides will get W added, right? So it's twice W. So these are the areas. And finally, if you add this for all of the n squares, this is nothing but your value C, right? And now see, if you increase your W, your C value is C, final C is going to increase. If you decrease your W, your C value will decrease. So this is a monotonous increasing function, right? So what we can do, we can apply binary search. And we'll try to locate dark W, for which we get the value of C as given in input. So first of all, is this thing making sense? Why we are applying binary search? Like how we are going to apply it, like I'll discuss it later. But first of all, is this there? How is binary search applicable here? Yes. So okay. So initially, we take the value W, like the minimum value, low value as 0. More than 2E9, right? And this value will be like if you try to find an area of this square which has a side more than 2E9, you will get something like 4E18, and your C value is going only up till 1E18. So it's like it's more than enough, this value. Is anyone having any doubt why I took my high as 1E? Probably something lower than this will also work. Yes, no, anything? Okay. So moving forward, we have our mid as low plus high by 2, like in usual binary search, right? And then what do we do after this? We'll consider this mid as our W, and we'll calculate the final areas, like the total areas of the square, total area. How? We'll go through each of the square sides as I, and for this SI, we'll add this 2 times mid, and we'll calculate the square for this for each of these squares, and we'll add this value to our total area. Finally, we'll compare this total area. Let's call this as TA, and we're going to compare this TA with our C. If this turns out to be equals to C, we can simply output the value mid. that is nothing but your W. If TA turns out to be more than C, you can simply do high is equals to mid minus 1. And if TA turns out to be less than C, just do low is equals to your mid plus 1. So if this is clear, okay, can I repeat the last part? See, TA is nothing but your total area. If total area is equals to C, then that means you have found your W, right? But if TA turns out to be more than C, this means that the W that you're taking as your border, you have taken more border. That's why you got more area, right? So it is not possible at mid, therefore you're shifting your high boundary to mid minus 1. This is simple BFS, not BFS, BS, binary search. Okay. Okay, so let's look at the code. So this is the implementation. Now, some people are writing that they are sharing their code and they're telling me that they had some issues. It's probably because of overflow. But anyway, just raise a query and tag me in it, and I won't be able to discuss your approaches or how you implemented this problem right now. But I'll surely look into your codes or your implementations once this session has ended. Okay, just raise a query and tag me. So this is the implementation that I did, and in this I have N and C. So N is the number of squares that I have, and C is the total area. I'm taking that as input, then I'm taking my S as input. Yeah, and then this is a 128-bit integer. It is nothing but, see, a long integer is having has 64 bits, right? A usual int 32 has 32 bits. Int 128 has 128 bits. I'm not sure that you actually require this, but I just took it just for making sure that the solution doesn't faces any overflow issues. And yes, it's available in C++17. It's available in all C++ modules. Versions as far as I remember. But they may be you may require some other separate modules than the usual modules to support this in your local machine. But anyway, so this low is 0 and high is 29. Then mid is low plus high by 2. And you don't actually require this in 128. You can work with the long run also, because C is 118 also. You can check here. You need, if this val actually turns out to be negative, that this simply means that you have a value more than C if it turns out to be negative, right? But you'll have to check more than that, because sometimes it's possible that because of overflow, you got a value which is less than the C, but it's not negative. So anyway, this is the mid and my value is 0. So I'm calculating the total area. So val will have the total area. And then I'm checking if val is equals to C. I'm simply printing it. This is nothing but converting my mid to long. So I'm printing this value and I'm breaking this loop. Otherwise, if val is less than C, I'll move my left boundary to mid plus 1. Otherwise, I'll move my right boundary to mid minus 1. Is it clear? Okay. Okay, so someone is saying that yeah, they are not able to raise query button. I'm not aware of anything, but yeah, I'll talk with the managers, and in case you still have any doubts, you want me to look into your code, we'll find a way. Okay. but I'm not sure like right now is the time to like discuss your implementation, because maybe after this session, just to wait, I'll stop the recording and we can discuss your implementation. Okay, because the recording will actually get uploaded on the YouTube channel, and also like right now there are other peoples on this call and their time will be wasted if I start looking into your code. Okay, how are we calculating the area? This is nothing but side square. See, E is the side of the original square, and mid is the W that I'm taking, the margin. So it's added on all the four sides. So this is the modified length and this is the modified height. Is it okay? Like someone asked, how is the area getting calculated? Okay, so we'll move to the next problem. So this is the next problem, and in this problem we are given that there are n frogs and number from 1 to n, and initially all of the frogs are located at the point 0, and frog I has two hop length ai. And okay, someone asked, like if you're talking about the previous one, it's not actually required, it's just a small implementation detail. So I have multiplied with 1 ll so to make sure that the overflow doesn't happen. Okay, so in this problem we are given that there are two kids, and these have a group of, they are looking for at a group of n frogs, and these frogs are numbered from 1 to n. So initially each of these are located at point 0, and frog I has a hop length of ai. Now each second frog I hops ai units forward, and before any frog starts hopping, Salvik and Mihai can Slavik and Mihai can place exactly one trap in a coordinate in order to catch all the frogs that will ever pass through that corresponding coordinate. However, the children can't go far away from their home, so they can only place a trap in the first n points, and they cannot place at point 0. So let's look at this problem here. See, we have some frogs, and for those frogs, all the frogs initially, let's say this is the value of n. We have something like this, and each of these frogs is initially located here. And if the frog, like hop length for this frog is 5, for this it's 3, and for this it's 2. So this frog is going to jump like from this place, it's going to 5th, 1, 2, 3, 4, 5, right? Like this way, it will keep on going, and similarly this thing will go from this, then this, then this. It will continue, right? Like I'm not actually sure that whether you have to jump 3 blocks forward or you have to skip 3 blocks and then jump to the next block. But anyway, you get the idea, right? So finally, we can put a trap. Okay. We can put a trap on any one of these cells or coordinates. And finally, any frog that is going to jump at this place is going to get trapped in this coordinate. So in order to catch maximum number of, like what is the maximum number of frogs that can be caught? This is the problem. So is the problem statement clear? Okay, what is, okay, I'm talking about, like, let me go through. Yeah, it's frog I hops AI units forward. So this means that like the thing that I drew was correct. Yep. Yeah, we skip AI minus 1 steps. We don't skip AI. We just go like if we are at 0th step and the frog like this AI value is 3, then we'll go from 0 to 3, not 0 to 4. Okay. So how to do this? See, first of all, you can solve this by, see, first of all, just count how many frogs have a value of AI value equals to 1. All of the frogs have values less than, if we look at here, the frogs have values 0. They have values between 1 to n, and n is 1 to 10 to the power 9, and n is between 1 to 2 into 10 to the power 5. Now, count the frogs that have their AI values 1, 2, 3, all the way till n. Now, for all of these one values, see, we can easily make an array of length n, right? Because n is up till 2 into 10 to the power 5. Then, what we can do, start from here and start like, let's say this count 1 appears x times. The number of frogs that have AI equals to 1 is appearing x times. So the number of count of these frogs is x. So we'll keep going one step forward, and we'll add for all of these x all the way till here, right? Then for these two, let's say this is appearing 2 times. So y times these frogs which have AI is equals to 2 appear y times. So we are going to update every second place with this value. Then let's say this 3, the frogs that have AI is equals to 3 appears z times. So we're going to update every third position with this value, add z value. Finally, the position which has the maximum value, we'll output that value, the maximum value. Why? Because those are the number of frogs that we can actually get, we can actually caught. Those are the maximum number of frogs that we can actually catch, right? And I'll discuss the time complexity in a moment, but first let me know, is this clear? Like how to solve this problem? Let me know is okay. So it's clear, but what is the time complexity of this? Like if we implement something like this, so let's discuss the time complexity also. See, in worst case scenario, you will have 1, and you will have all these 1, 2, 3 till n appear exactly once. So then you'll have to iterate for all of these values, right? So how many times you're going to do for 1? You're going to iterate n times. For 2, you're going to iterate n by 2 times, right? Because you'll keep shifting, you'll skip half of these cells. For 3, you'll go n by 3. For n, you're going to do 1. So what is the sum of this 1 plus, like, what is the sum of n by 2, n by 3 till 1? It is nothing but log n log n. So the time complexity of this thing is this. This is actually, yes, it's like the complexity of Steve. So if this clear, we'll move to the implementation. And this is the, okay, let me check. Yeah, this is the implementation. And in this, for counting, I've used an unordered map because this doesn't add any extra time complexity constraints, right? Time complexity constants. So then, first of all, I'm counting for each of these, like how many times a value is appearing in A. Then vals is how many frogs can be caught in the ith coordinate. And then for each value A, like A is the value that is in my array A, the AI value, and B is the count of it, how many times it's appeared. So I'm starting from A, and I'll keep moving A times ahead. And then while I'm at a position which is less than or equal to n, I'll increment this value by B. B was nothing but the number of times this value was appearing in array. Finally, I'm printing the maximum value that is in my vals array. Is it clear? Yes, no, anything. Okay, it's clear to some people. What about others? Okay, if in case anyone is having any doubt, let me know. Otherwise, we'll move to the next problem. Okay, so let's go to the next problem. So this is the next problem. And in this problem, we are given that a compass points directly towards the morning star. Yes, again got disconnected. Let me, I'm audible, right? Yes, no, anything, or is my voice breaking? Is there any lag in, like, can you feel any lag in my voice? Okay, no lag. Okay, thank you. And I'll start the, I think the recording is going on, or okay, the recording is still going on. So let me start my screen share. So this is the problem that we were discussing, and in this problem we are given that a compass points directly towards the morning star, and it can only point in one of the 8 directions, the 4 cardinal, that is north, south, east, and west, and some combination like northwest, northeast, southwest, and southeast. Otherwise, it will break. So there are n distinct points with integer coordinates on a plane, and how many ways can we put a compass at one point and the morning star at another so that the compass does not break? So basically, we're given n points on a card, 2D plane like this, and we can keep, like, these are the 4 directions, right? These are the 8 directions. These are the 3 directions. So if we decide to keep our compass here, we can keep a morning star anywhere here, right? Or like if we decide to keep our morning star or compass here, we can keep our morning star in any of these 8 directions, right? But we cannot keep it here. So given these endpoints, we have to find how many 2 points, like in how many ways we can select 2 points in which we can keep our morning star in one point and the compass in another, so that our compass doesn't break. So first of all, is the problem statement clear? Is the problem statement clear? Okay, so see, if it's clear, this problem is very easy. We can just check how many, see for this point, if I'm saying that, see, these are the 8 directions, right? These are the 8 cardinal directions. So if I'm at this point, I can simply check how many points have the x coordinate as this point, and I'll add all those points in my answer. Then I can check how many points have these x coordinates as this point, and I'll add all those points in my answer. How to get these points? See, this is the line which is y is equals to x. So y is equals to x plus c, maybe something constant, right? This is the equation of this line. So y minus x is constant. So for all of the points which have the same y minus x value as this point, I'll add all those points in my answer. And what is the equation of this line, by the way? Anyone? It is y, yes, somebody has already said in the chat, it is y is equals to minus x plus c. So this means y plus x is a constant. So for all the points which have the same value as for this point, the value which is x plus y, I'll add all those points in my answer. So finally, you can compute for all of these, and the value that you'll get is your final answer. So if this is clear, we'll move to the implementation. Like it will be much more through the implementation. Like this will be much more clear. Okay, can I repeat again? Okay, let's first go to the implementation. If you still have any doubt, let me know, because it's much more clear through the implementation. See, first of all, I'm taking m as input, then I'm taking all the endpoints as input. Then I've created an ordered map of that is an array of size 4 of type unordered map. So the first unordered map here, that is the first part of my array, will have the count of all the points that have this x coordinate as their, like this value as their x coordinate. Then the first, that is the second unordered map, will have the count of the points that have this value as their y coordinate. Similarly, this is for the third and the fourth unordered maps, these values, right? You can write this as y minus x or x minus y, it doesn't really matter, this value. So you can actually create 4 different unordered maps or just create one unordered map. Then finally, for each of the points, add all of these values, and you have to subtract 4y, because in each of these 4 counts, like each of these 4 points, there is this point also included. Like this point x comma y is itself included in this count once, right? So you have to decrease once from here, from here, from here, and here, because this point had contributed to all of these 4 counts. So that's why decrease 4. Other than that, all the remaining positions are the valid positions for keeping. Let's say at x comma y, I'm placing my compass. So all the other remaining positions are valid positions for like keeping the morning star there. That's why I'm not doing answer by 2. Make sure that you're not doing, because this position, those two like positions are different. Like if you select 2 positions as a, let's say 0.1 and 0.2, and next time you selected 0.2 and 0.1, so these are different. Why? Because at 0.1 first time you're keeping compass, and in the second, in 0.1 you're keeping your morning star. So that's why. And finally, print answer. Is it clear? Okay, it's clear. Okay, so let's go to the next problem. So this is the last problem, and in this problem, we were given that in order to win his toughest battle, Mirkia came up with a great strategy for his army, and he has sent soldiers and decided to arrange them in a certain way in camps. Each soldier has to belong to exactly one camp, and there is one camp at each integer point on x-axis. At points, like, for each of these points, there is a camp. The strategy consists of m conditions. Condition I tells that the AIH soldier should belong to camp that is situated at DI meters in front of the camp of the person BI belongs to. In the camp that person BI belongs to. Now, Mirkia wonders if there exists a particular situation or particular partition of soldiers that respects the condition that he asks, like that he requires, and he asks for us for our help, and we have to output yes if there is a partition of n soldiers, otherwise we have to output no. And we can put like more than 2 soldiers in one camp. So see, when will be the answer, when we will have yes as an answer and when we will have no as an answer. See, we will have no only when we have a contradiction, like A, we have B 5 meters ahead or 5 units ahead of A, and we have A 3 units behind B. So this is a contradiction, right? I can have something like more complex, something like this. A is 5 units ahead of B. B is like maybe 3 units behind C, and C is finally C is 10 units in front of D, and D is just 1 unit behind A. So this doesn't actually add up, right? Because between D and C, you should have at least 10 units. But if you count between these three, you'll get the sum of 9. So this is a contradiction. So in these cases, you'll get a no. But you can actually keep, if you have something like B, if this was 2 and you had at least like it's 3 meters or 3 units. I think it's like, what are these distances? It's meters only. So it's like, let's say C is 3 meters ahead of B, and there is some other guy E, which is also like, which is 8 meters ahead of A. So this is possible that both of these are in the same camp. So, but in case of only contradiction, we'll output no. When we have something like B is 3 meters ahead of A, C is 2 meters ahead of B, and A is 4 meters behind C. So this is a contradiction. Then only we'll have no. So first of all, is the problem statement clear? This is what is asked. Like, it is asked whether or not we can have one of the, like, is it possible or not, the situation that we have provided. Okay, the problem statement is still not clear. See, we are given that we have M conditions, right? Condition I tells us that the AIH soldier should belong to a camp that is situated DI meters in front of the camp that person BI belongs to. If DI is less than 0, then AI's camp should be D minus DI meters behind BI camp. So if all of these conditions, like, there's a way that all of these conditions satisfy, we'll output yes, otherwise no. And more than one soldier can stay in a camp. So all I'm saying, see, our answer will be no only when we have a contradiction kind of thing. Like, B is 3 meters ahead of A, C is 2 meters ahead of B, and we are saying that, okay, there is another condition which is saying that A is 4 meters behind C. So this is a contradiction, right? Because A and C should have 4 meters according to this distance, but according to these conditions, these two conditions, A and C should have 5 meters. So this is a contradiction. But if this was indeed 5, then the answer would have been yes. So is the problem statement clear now? Yes, so the problem statement is clear. So, like, actually somebody has already written in the chat how to solve this, because see, once you get the idea of the problem statement, you can actually use simple DFS. Simply use DFS. See, if a vertex is not visited, keep marking the vertices as visited. And if a vertex is not visited till now, just start your DFS from that vertex. Say that, okay, I'm keeping this vertex as camp 0, camp which is located at point 0. Why 0? Because you can keep it at any value which you like, because you just need a contradiction, right? You can keep all the soldiers in just one camp. So you can, or keep any soldier, like you can decide to keep this at 10 to the power 9 also. Choose any random value and then try to, with respect to this soldier, try to like allot the camps to other soldiers. Like there was a soldier which should be 5 meters ahead of this. So if this is at 0th camp, this should be at 5th camp. Or the camp which is at x equals to 5, then there is another soldier which should be 100 meters ahead. So this will be at 105. Then there is another soldier which is at, let's say, like there's a camp or soldier, like this is this is maybe 200 meters. This is telling you that this should be 200 meters behind another soldier. So this should be 305. Now, let's again, there is another like condition that this soldier should be 305 meters ahead of this soldier. So now you can check that, okay, this soldier has already been visited. So you have a value for it. So simply check that if you subtract the distance of like the position of this soldiers, and you from that you subtract this value. So whether or not you're getting the value at which this soldier is already present. If it's true, you just simply continue. Otherwise, you mark your flag as 0, flag as false. Otherwise, your flag remains true. So this simple DFS, like if you're not getting the idea, okay, let me show you the implementation. It will be much more clear. This is an implementation detail, right? So first of all, I'm taking my graph as input. So see, if from A to B, if I'm getting, see, A should be, like B should be, let's look at the problem. So if I was given A, B, this meant that, okay, where is the condition that A should be belong to a cam that is DI meters in front of cam BI, right? So A should be in front of B. So that's why this simply means that B is DI meters behind, D meters behind, and B is like B is D meters behind and A is D meters in front of B. So these are this is what these edges mean. So I've made this kind of graph, and this simply means, see, if A is having this B comma D pair, this means that B is these minus D meters behind A, and this means A is these D meters in front of B. Then I've created a map. This is the value, like at which position I am having my soldiers at which camp, and these are those soldiers, the number, the count, like because I need to check right quickly. And this is long end because that value can actually go like be very large. So see, first of all, if the current soldier is not visited, I'm clearing my map and then I'm starting my DFS. So first of all, this is the distance, right? Initially, I'm keeping it as 0. So I'm inserting my U, that is this soldier in my, for this, in this map, corresponding to this map, which whatever set is there, I'm inserting this U. Then I'm marking this current vertex as visited. And then for all the neighboring vertices, I'm checking if they were not visited. Now I'm starting my DFS from that, and the point or the camp to which this VS soldier will be located with respect to this US soldier is nothing but distance plus D, right? If it is negative, then this soldier will move to the previous position. Otherwise, like the DI meters behind, or if it was positive, this VH soldier will take a camp which is D meters ahead of this UH soldier. If it has already been visited, that is this VH soldier has already been visited, I'm simply checking that F, and F is nothing but my flag, right? Initially it's 1. That is true. That at this value, distance plus T, because at distance plus T, there should be, at this camp, there should be soldier V present, right? So I'm simply checking that at this camp dot find V. That means at this set, my value V is actually present. If it's visited, this soldier has already been visited. So I'm simply checking that this is not equals to MP of this value dot end. If finally my F is 1, I'll output yes, otherwise no. So this is simple DFS. You can implement this in many ways. Yeah, you can use, like distances can actually be very large. See, your given values, distances can go up till 10 to the power 9, right? And you have 2 into 10 to the power. So your final, like the maximum distance, if you start from 0, can go to up till 2 into 10 to the power 14. But yeah, there are other ways to work around this. You don't actually have to follow this strictly. You can implement this in many ways. So if no one is having any doubt, we'll stop. You'll get the links to all of these codes probably within some hours. Okay, the managers will share the links with you. So that's it for today. Thanks for joining. Bye.